Okay, so question 1. A plane starts at rest on a straight runway. For the first 30 seconds, the plane's acceleration, a, is given as a function of time t by the equation a equals s set. I think that's probably supposed to be a beta. I know this from German. Whatever. S set, beta, whatever, t squared, where beta equals 1/90th meters per second to the fourth, and t is in seconds. What is the plane's speed at t equals 30 seconds? So the concept that this is based on is the derivative relationship between velocity and acceleration. Because acceleration is the derivative of velocity, that means that if we have the acceleration, we can take the integral of that to find the velocity. So if we have a equals beta t squared, and we take the integral of that, so the integral of beta t squared dt, where beta is equal to 1/90th meters per second to the fourth, we can pull the constant out of the integral, and then we have 1/90th meters per second to the fourth times the integral of t squared dt, which is equal to 1/90th times 1/3 t to the third plus c, which comes out to 1/270th t cubed, or t cubed divided by 270 plus c. Now we can use this function to solve for the velocity at t equals 30 seconds. So if we take this function and we just plug in 30, so 30 cubed divided by 270, I don't really care about the plus c. Just plug this into a calculator. 30 cubed divided by 270 is equal to 100 meters per second. I guess let's talk about the units. So if we have a equals beta t squared, where beta is equal to 1/90th meters per second to the fourth, the reason that makes sense is because acceleration, the unit for acceleration, is meters per second squared. And if we have a is equal to beta t squared, the unit for time is seconds, so that gives us seconds squared. And in order for us to have the correct units for acceleration, acceleration is equal to beta meters per second to the fourth times seconds squared. The seconds squared will cancel out two factors of the seconds in the denominator of those units, giving us acceleration is equal to meters per second squared. That's going to be all weird backwards, I think.